Hi guys, welcome back to our channel. In this video, we are going to be discussing about contiguous memory allocation presented by CH Manognya 22B0 1A0 530 G Sudha Madhuri 22B0 1A0 548 under the guidance of Dr. M. Prasad Sir, PhD, Associate Professor, Department of CSE, SWEC, Bhimavaram. Memory allocation is of two types: contiguous memory allocation and non-contiguous memory allocation. So let's move on to the introduction. Allocating space to software application is referred to as memory allocation. Contiguous and non-contiguous memory allocations are the two types of memory allocations. Contiguous memory allocation enables the tasks to be finished in a single memory region. Non-contiguous memory allocation distributes the procedure throughout many locations in various memory sections. The contiguous memory allocation is one of the methods of memory allocation. In contiguous memory allocation, when a process requests for the memory, a single contiguous section of memory block is assigned to the process according to its requirement. In the above picture, you can see all the tasks are assigned in a contiguous way in the sequential manner. Contiguous memory allocation. All the available memory space remains together in one place. It means free available memory partitions are not expanded here and there across the whole memory space. Both the operating system and the user must reside in the main memory. The main memory is divided into two portions. One portion is for the operating and other is for the user program. When any user process requests for the memory in a single section of the contiguous memory block is given to that process according to its need. Purpose of contiguous memory allocation. The process of contiguous memory allocation in operating system is to efficiently manage the memory resources available on computer system. By allocating memory to processes in contiguous blocks, this technique ensures the memory is utilized efficiently with minimal fragmentation and wasted memory. This results in faster access of memory. As contiguous blocks of memory can be accessed more quickly than non-contiguous blocks, additionally, contiguous memory allocation simplifies memory management by allowing the operating system to manage memory in larger blocks rather than small fragmented pieces. This reduces the overhead associated with managing multiple memory blocks, leading to faster system performance. Overall, the purpose of contiguous memory allocation is to ensure that memory is efficiently utilized and effectively managed, resulting in improved system performance and faster access to memory. This is particularly important for applications that with high memory requirements such as multimedia editing, gaming, and for systems with small number of processes that require fast access to the memory. Now let's look at characteristics of contiguous memory. There are four characteristics that are efficient use of memory, easy to manage, external fragmentation, and compaction. Let's look at efficient use of memory. Contiguous memory allocation is efficient in terms of memory utilization, as there is no internal fragmentation within a process's allocated memory block. Now, let's look at how it is easy to manage. Contiguous memory allocation is easy to manage as the operating system can quickly allocate and deallocate memory to processes by assigning contiguous blocks. Now, let's look at external fragmentation. One of the main drawbacks of contiguous memory allocation is external fragmentation, which occurs when small gaps of free memory are scattered throughout the memory space. Over time, these small gaps can accumulate and result in larger portions of memory becoming unusable, even though the total amount of free memory may be sufficient to satisfy a request for memory. Now, compaction. To address external fragmentation, operating system may use techniques such as compaction, where the operating system rearranges memory blocks to eliminate gaps and consolidate free memory into larger contiguous blocks. So these are the main characteristics of contiguous memory allocation. So this is a optimistic way of sorting the data in a more compact and a more classified way. Now my friend will continue with approaches to implement contiguous memory allocation.
Till now, my friend discussed the topics like memory allocation and its introduction, and contiguous memory allocation and its details, and the purpose for contiguous memory allocation and the characteristics of contiguous memory allocation. Let's go further on it. Let's see how contiguous memory allocation further divided into, or the approaches to implement contiguous memory allocation. From this flowchart, we can clearly understand that contiguous memory allocation is divided into two types. First one is fixed sized partition and the second one is variable sized partition. By the term fixed, we can understand that it is fixed, and by the term variable, we can understand that it is not fixed and it can change. Let's go deeper into it. Let's see the first one. Let's see one of the approach to implement contiguous memory allocation, that is fixed size partition. The another name for fixed size partition is static partitioning. In this case, the system gets divided into multiple fixed size partitions. In the fixed size partition, every partition may consist of exactly one process. That means every partition have exactly one process. The next point is each partition is typically allocated at system boot time and remains dedicated to a specific process until it terminates or releases the partition. That means every partition contains single process until it get terminated. Terminated means until it get completed, it is allocated to that specific process. And the next point is when a process requests memory, the operating system assigns it to the appropriate partition. Each partition is of the same size and the memory allocation is done at the boot time. That means each partition is of same size, means every partition is of same size and memory allocation is done at the boot time. Let's see an example for it. Let's go through an example for fixed size memory allocation. The question here is three processes in the input queue that requires memory space allocation. The three processes namely are P1, P2 and P3. Here P1 requires 3 MB memory space allocation and P2 require 1 MB and P3 require 4 MB memory space. Here the solution for this problem is, firstly, the memory have fixed chunks because we are using the fixed size partition technique. In addition to 4 MB process, the first process which is in size of 3 MB is given 5 MB block and the second process which is of 1 MB in size is also given 5 MB block. So we can understand that it does not matter how big or small the process is. The same fixed size memory block is assigned to each. Here in the diagram you can clearly see that each partition have 5 MB memory space. Whether the process may be 2 or 3, it is given 5 MB for its execution. So this is how a fixed size partition works. Let's read the advantages and disadvantages of fixed size partition. Let's look into the advantages first. The first advantage is it is simple and easy to implement. The second advantage is it is predictable, means the operating system can ensure a minimum amount of memory for each process. And the third advantage is it can prevent process from interfering with each other's memory space, improving the security and stability of the system. These are the advantages of the fixed size partition. Let's look into the disadvantages. The first disadvantage is it can lead to internal fragmentations where memory in a partition remains unused. Fragmentation generally means unwanted problems occurs in the OS, and this can happen when the process memory requirements are smaller than the partition size, leaving some memory unused. Additionally, fixed partition limits the number of processes that can run concurrently, as each process requires a dedicated partition. These are the disadvantages of fixed size partitions. Let's see the second approach to implement contiguous memory allocation, that is variable sized partition. It is also called as dynamic partition. The scheme allocation in this type of partition is done dynamically. Here the size of every partition isn't declared initially. Only once we know the process size, then we will know the size of the partition. In the variable sized partition, the size of the process and the partition is equal. Thus, it helps in preventing internal fragmentation. We need to keep in mind that the size of the process and the partition are equal because it is dynamically allocated. And the next point is, on the other hand, when a process is smaller than its partition, some size of the partition gets wasted, that is internal fragmentation. It occurs in static partitioning, and dynamic partitioning solve this issue. Let's see an example for variable sized partition. Let's look into the picture. Here it represents that block diagram of dynamic partition. The operating system occupies some part of the partition, and the P1 process of size 2 MB occupies 2 MB partition size, and P2 process of 7 MB occupies 7 MB partition size. From this we can clearly say that size of partition is equal to size of process. Let's go further on it. Suppose in the given example, process P1 of 2 MB and process P3 of 1 MB completes their execution. Hence, two spaces are left, that is 2 MB and 1 MB. Let's suppose process 5 of 3 MB comes. The space in memory cannot be allocated as no spanning is allowed in contiguous memory allocation. That is, if process 1 and process 3 completes their execution, which are total 3 MB size. If process 5 comes with the need of 3 MB memory allocation, then it is not allocated to it because of contiguous memory allocation. The rule says that the process must be continuously present in the main memory to get executed. Hence, it results in external fragmentation. See advantages and disadvantages of variable sized partition. Let's look into the advantages first. In variable partitioning, space in the main memory is allocated strictly according to the need of the process. Hence, there is no case of internal fragmentation. There will be no unused space left in the partition. The second advantage is more processes can be accommodated due to the absence of internal fragmentation. A process can be loaded until the memory is empty. And the third advantage is no limitations on the size of the process. Let's look into the disadvantages. First disadvantage is implementing variable partitioning is difficult as compared to fixed partitioning, as it involves the allocation of memory during runtime rather than during the configuration. And the second disadvantage is there will be external fragmentation despite the absence of internal fragmentation. These are the advantages and disadvantages of variable sized partition. Let's discuss the last part of our topic, that is pros and cons of contiguous memory allocation. Let's look into the pros first. The first one is it supports a user random access to files, and the second one is the user gets excellent read performance, and the third one is it is fairly simple to implement. These are the pros. Let's look into the cons. Having a file grow might be somewhat difficult, and the next one is the disk may become fragmented. These are the advantages and disadvantages of contiguous memory allocation. I hope this video is really useful to you. Thank you for watching.